Okay, let's dive right in. Welcome to our explainer on one of modern medicine's absolute wildest mysteries, how anesthesia actually works. Every single day, thousands and thousands of people undergo surgeries, right? The doctor pumps a highly specific chemical cocktail into your body, and you don't feel anything, you don't remember anything, and for a short time, you essentially go entirely offline. We treat it as this mundane, perfectly understood part of modern science. But as we're about to see, the science behind putting a human being to sleep is anything but simple. In fact, it is wonderfully, deeply confusing.
So, the crucial point to understand right out of the gate is that when you go under, you aren't just taking a nap. You effectively stop existing, and doctors aren't entirely sure why. Your doctor doesn't just press some magical red button and watch your consciousness fade away. They're actually orchestrating a highly complex biological interruption using a very precise mix of drugs. We know exactly how to administer it, and we know the exact dosages to keep you perfectly safe. But the fundamental underlying mechanism of exactly why your consciousness vanishes, that remains a massive medical blind spot. And, it's literally crazy. This whole fading out thing isn't just a human phenomenon. This special juice even works on plants. Yeah, if you expose certain sensitive plants to anesthetic gases, they actually stop reacting to touch entirely. They completely lose their ability to move their leaves. This highlights something incredibly profound. Whatever anesthesia is doing, it's hacking into a fundamental, base-level biological system that spans across vastly different forms of life. It's not just some weird human brain quirk. It's practically a universal pause button for living cells.
Okay, to figure out what's going on, let's build our baseline. Think of it kind of like a boxing match. In the blue corner, you have local anesthetics. You don't want to feel your arm during a procedure. Boom, the nerve signals in that one spot are blocked, but your consciousness remains totally intact. In the red corner, though, you have general anesthetics. These are the heavy hitters. They don't just block a local nerve. They travel all the way up into your brain through your veins or your lungs and take you completely out of the driver's seat. So what's actually happening up there? When we look closely at what these general anesthetics are doing once they hit your brain cells, things get super fascinating. Your brain works by having cells talk to each other using neurotransmitters, which basically act like keys opening gates on a cell, letting positive or negative ions flow in. If enough positive charge builds up, the cell fires and sends the message along. But the anesthetic chemical, it acts as a total imposter in this delicate communication network. The drug triggers a process we can basically call cellular spamming. It sneaks in looking like a big, burly, negative neurotransmitter. It throws the cell gates wide open, flooding the whole thing with a negative charge. But your cells are smart, right? They have a defense system. When it gets too negative, the cell counters by forcing open special positive gates to offset the balance, causing the cell to fire anyway. The result? The anesthesia essentially spams the cell on and off, on and off. And the more drug that enters, the longer those off periods become. But guys, here is the massive medical mystery. Does this rapid flickering actually shut off your consciousness, or does it just give you extreme amnesia so you simply forget feeling the surgery? This is where things get incredibly messy. If your brain cells are just rapidly flickering, are you truly gone, or are you sitting there experiencing the entire terrifying ordeal of surgery only to have your memory wiped totally clean the very moment it's over? To solve this puzzle, we actually have to take a step back and define what unconsciousness even means. Back in the 1840s, when anesthesia was first introduced, the standard was incredibly basic. It simply meant a patient failed to respond to a doctor's command. The doctor would tell you to do something, and if you didn't do it, well, congratulations. You were deemed unconscious, and the surgery would begin. But looking at this through a modern lens, we realize how dangerously simplistic that definition really is. Let's dive into the massive logical flaw here. Just think about sleep paralysis for a second. During sleep paralysis, you absolutely cannot respond to a command, but you are still completely 100% conscious. If you've ever experienced it, you know exactly what I mean. You're entirely aware of your surroundings, you might be totally terrified, but you're utterly incapable of moving or responding. So merely being unable to respond does not mean you are unaware. To truly be unconscious, you have to lack both the ability to respond and the awareness of your own existence. Which brings us to a totally mind-bending case study that basically challenges everything we thought we knew. Enter the unique cocktail known as ketamine. To figure out if anesthesia is just paralyzing us or actually turning off our awareness, scientists look really closely at how different drugs affect the brain. And ketamine is famous in the medical world precisely because it completely shatters our standard expectations of what it means to be put under. Now, with ketamine, you are actually conscious and you're fully able to move, but the drug severely impairs your willingness to respond. It doesn't paralyze you at all. It essentially disconnects your conscious mind from caring about what is happening to your physical body. You could theoretically sit up and interfere with the surgeon, but you're completely indifferent to the fact that someone is taking a scalpel to you. You simply exist, feel absolutely nothing, and then forget the entire bizarre experience afterward. Now, propofol is much more commonly used today, but researchers found that if they give you just a slightly lower dose, it reveals something totally wild. A doctor can ask you to do something and you won't do it. Not because you're asleep, but because your short-term memory is instantly being erased in real time. The drug literally causes you to forget a command the exact second after it was asked.
To figure out what was really going on, researchers designed an incredibly spooky tourniquet experiment. They wanted to know, are patients actually experiencing the surgery but just paralyzed and forgetting it? So they lowered the dose, isolated a patient's arm with a tourniquet, and then injected the special juice so that the muscle relaxants couldn't reach that one specific arm. By cutting off the blood flow to the arm before injecting the muscle relaxants, they created a crazy scenario. The patient's brain was under the anesthetic, but one single arm was completely free to move.
So the crucial point here is the downright terrifying result. These patients couldn't move their bodies at all, but they could use that one isolated arm to answer yes or no questions with what researchers called unusually comprehensible wiggling. When the doctors asked questions, the rest of the body was locked down, but that one unmedicated arm began moving. The patients were actively listening, processing the questions, and communicating back to the researchers right in the middle of the procedure. But here's where the amnesia theory really takes hold. Despite having these full-on, hand-wiggling conversations, once the drugs were off, the patients completely denied ever being awake. After the experiment, the researchers would ask them about their experience, and every single time, the patients claimed they were completely unconscious the whole time. They had absolutely zero memory of the finger-wiggling conversations they had literally just participated in. It just goes to show that a patient's own testimony about being unconscious really isn't reliable at all.
So, does a full, normal dose actually make you unconscious? Well, when we compare it to regular sleep, anesthesia actually looks way more like a mini coma, with just a tiny bit more brain activity. When we look at the brain scans, being under a full dose of anesthesia doesn't look like sleep in the slightest. It closely mirrors a comatose state. Because of this massive depression in brain activity, the medical community assumes that, yes, at proper general anesthetic doses, you truly are unconscious, not just trapped in some amnesiac paralysis. That cellular spamming literally forces your brain into this mini coma state. Which brings us to our final, totally mind-boggling cliffhanger. Our ambiguity in figuring out anesthesia isn't really a failure of chemistry. It's because we still have absolutely no clue what human consciousness actually is. We know the chemicals spam the cells. We know the cells flicker. We know it puts the brain into a mini coma. But because we can't definitively point to where you exist in the brain, we can't perfectly explain how a chemical turns you off. Are we just a collection of firing neurons, or is consciousness something deeper that these drugs temporarily sever? It's a mystery that leaves us all a little confused, but honestly, utterly fascinated. So next time you or someone you know counts backwards from 10, ask yourself, where exactly do you go when the numbers stop?